This
design,
conference
and
will now be recorded.
this is now the requirement. What is the ECBC, ECBC plus and super ECBC, which is mandatory requirement. ECBC is the only mandatory, and the ECBC plus and super ECBC is the voluntary approach as of now. And the target is to create the net zero energy buildings. Net zero energy building where the energy by the energy generation. The total energy consumption would be offset by the energy generation, so that your building have completely net zero energy building. So this ECBC, we can set if we can save energy efficiency in the buildings, and as per the simulation approach, we can reduce the energy efficiency, or we can reduce our energy consumption by 40 to 60% as comparison with the conventional buildings. So there is another update, which is ECBC-R, ECBC for residential buildings. This is another major update which is released by Ministry of Power, Government Bureau of Energy Efficiency, Government of India. Eco Niwas Samhita, it is known as Eco Niwas Samhita, ECBC-R for residential buildings. It has been released and it is now being implemented by the state at state levels. Eco Niwas Samhita, building envelope only. This building envelope have been designed, and it needs to be implemented in such a way. We all know residential electricity consumption is increasing by 40 to 60%. Electricity consumption is increasing day by day in the residential sector, because we all know we are moving from the horizontal surface to the vertical surface now. So we are shifting to 2 BHK, 3 BHK type of building, which are multi-family residential building or tall buildings, we can say. So what are the types of parameters which we need to focus? All such design parameters. The parameter first is the orientation. We need to define our building in such a way so that it will not directly impacting to the heat gain inside the building. Wall type, how we can construct our building, like brick wall, cavity wall, AAC wall, brick wall with insulation and RCC wall. There are several type of parameters or several type of building construction or building wall assembly, how we can design and construct our wall assembly as per the requirement of ECBC R or ECBC 2017. So this is the window size and type. So window size as per the ECBC or energy efficiency of building. So total window area should not be more than 40% of the total wall area. So window wall ratio should not be more than 40%, and it should not be directly exposed to the sun. It should have with the shading devices, whether it would be horizontal overhangs or vertical fins in front of the windows, so that our window size and type would directly respond to the restriction of solar heat gain. Maximum U value of the building envelope and U value of the building, we need to see how we are defining our wall assembly and how we are defining our window assembly, so that it will not directly, the U value should be minimum. U value of any wall assembly or roof assembly, the U value is thermal transmittance, how the outside heat is directly impacting to the internal heat gain, which is the U value, which should be as low as possible. And Eco Niwas Samhita, the types of glazing, the single glazing and double glazing. There is no specific requirement mentioned by ECBC. ECBC just only talks about the SHGC, solar heat gain coefficient of the glass, and the VLT part. SHGC and VLT, solar heat gain coefficient. So the glass, your building glass should be in such a way that your SHGC should meet the requirement as per defined in ECBC, and your VLT of your windows, so visible light transmittance, so that you can capture the natural daylight which is available in the environment. You can capture daylight as maximum as possible through the glass property, which is VLT, visible light transmittance. It is as maximum as possible. And improve daylighting in the another part. Daylighting must be improved by providing the good glass and having low SHGC, good VLT, and the proper window area, so that we can improve our and can harness capture maximum daylight. Another is the thermal comfort requirements. How we can meet our thermal comfort requirement in our buildings. So thermal comfort requirement majorly talks about uh, the how the solar heat gain is directly impacting to us, and how we can maintain our thermal comfort requirement, which is around 22 to 27, if the outside temperature condition is around 45 to 48. We need first, we need to meet the natural ventilation requirement, improve natural ventilation, and the minimum 30% of the total CFM should be the natural ventilation we need to achieve and provide in the buildings. And limit heat gains in the summer season. Left picture defines the summer season, and right picture defines our winter season. How we need to limit heat gains in the summer season, and how we need to limit heat loss in the winter season. The temperature have been maintained inside should not be lost during the winter season, and the heat gain should not be directly impacting to the internal part of our surface if we can compare it with the summer season. So yeah, another factor is the integration with the renewable part. So these are all 5-6 parameter, which is just simple. Improved daylight, VLT, types of glazing. These are the simple parameters, simple definition, which you can just define your building, and your building would be CBCR compliant. And majorly, you will also go to achieve ECBC 2017 as well. You will be moving towards achieving all the requirements. So these are the specific brief requirements: improve natural ventilation, limit heat gains, limit heat loss, and integration with the renewable energy technologies. Renewable energy would be could be the solar panels, or it could be the biomass or geothermal. So what is the green building? Green building in this ECBC is one of the is part of the green buildings, and green building would be extended to the energy, water, materials, reducing impacts on the human health and the environment for entire life cycle of the building. Green building encourage you to use resources in efficient and economic way. Efficient and economic use of all resources, the green building, which is the extended version of ECBC. So green building is one which consumes less water, less energy, and it conserves natural resources, generates less waste, and it provides healthier space for occupants. These are the 5 major parameters: energy, water, waste, and indoor air quality and materials. Benefits of the green buildings: environmental, social, and economic. So these are the 5 parameters which we need to there are 3 major parameters, and the sub parameters which describe the biodiversity and ecosystem, improve air quality, water quality, conserve natural resources, which is under environmental benefits, and enhance occupant comfort and health, maintain minimize stress on local infrastructure, and improve overall quality of the life, which is under social benefits. And the building operational cost, whether it would be capital or operational cost, would be reduced in under economic benefits. And government are also providing tax incentives and subsidies for green building and renewable energy. So government are providing tax incentive or subsidies like 5% extra FAR, from 5% to 15%, depending upon the state to state. So impacts of the green building would be to reduce the carbon emission by 35%, reduce the water use by 40%, energy use by 50%, and solid waste by 70%. What are the green classification? Every type of building can now be classified as the green building. Green homes, green factories, green townships, green existing building, green metros, and green cities. And another major focus area is green healthcare. And we all can understand during this critical time how the green healthcare is of utmost importance, how we can implement design and construction with the green healthcare facilities as well. So, so these are some recommended building material. This is your answer when you ask some questions of how we need to develop energy efficient or green buildings. What are the recommended building materials? So these are various insulation scenarios how you can construct your wall assembly. Wall assembly should be the cavity walls by using the red bricks or fly ash bricks, or the AAC blocks you can use, hollow blocks you can use, and the perforated bricks you can use. So there are several type of material you can see in your pictures, and integrate it with the insulation part, whether it could be the glass wool insulation, rock wool, thermocol. Many types of insulation materials are available. You can use and construct your wall assembly as maximum as energy efficient, so that you can reduce the energy consumption, and your wall assembly would not directly passing the heat gain to the internal part of the building. So this is the example, and how the wall assembly helps us to reduce heat gain inside the building. If you will build, left side is the cavity wall, so less heat ingress to the building. And if you have single wall and only for the red bricks, so we would not directly recommend to use the red bricks or the single layer wall assembly. So it will enhance the heat ingress to the it will enhance the heat ingress to the internal part of the building. So we would encourage to create cavity wall or the wall assembly with the AC wall with the insulation part you can create. Another is the shading devices. In addition to the glass, window wall ratio should not be more than 40%. And in addition to it, you must use the shading devices. Shading devices could be the horizontal overhangs and the vertical fins. So these are the example for your reference, and you can see in your you can see your screen. So these are the example which you can use the shading devices, so that you can harness more and capture more natural daylight irrespective of the heat gain. So opaque construction and the roof how you can construct it with the RCC, above RCC or below RCC, how you can construct your roof assembly as the roof above deck insulation or below deck insulation. You can use the at the roof level, and you can also put the coated roof like white paint or white tile you can use over the roof part, over the exposed roof, so that maximum solar radiation would be directly transmitted back to the environment. It will not directly impacting to your internal part of your building. You can also construct it with the green roof as well. And the recommended techniques for glass, you can use the single glaze or double glaze, and it is preferable to use the shading devices, movable lowers and barrier, which you can see on your screen, how the fixed overhangs and lowers, horizontal overhangs, vertical fins, the trees, deciduous trees, long deciduous trees you can also use at the west side of your building, so that at the sunset time it will help you to circulate the fresh, cool air inside the building. Another is the recommended techniques for lighting. I am sure all of us we are using the LED lighting these days, but in addition to it, we can also integrate it with the occupancy sensor or motion sensors in our home as well. It is would be considered under ECBC for residential buildings. If you can use the occupancy or motion sensor in your office buildings, like director's room or uh, uh, officers, government officers, so that they can use the occupancy sensor, and when they left any room, So with the help of occupancy sensor, automatically all the lighting will be shut off. So it will help us to save energy in the lighting part. And it is recommended to use LED fixtures and energy efficient lighting appliances here, also in addition to it, internal lighting as well as the external lighting or outdoor lighting as well. So outdoor lighting can also be integrated with the solar street lighting, so that your energy consumption and your not much dependent upon the grid. And as we all know, the glass building we are constructing these days, tall buildings, glass building, and it is directly impacting internal heat gain as well, because there is no shading devices we can see over here. There is no shading device. So we know when we are constructing building, we need to make focus towards the glass building with the shading device. So this is an example. So these are the sensible building design can go a long way in reducing the cooling load to a great extent. So this is also one such example of glass building. So directly exposed glass, you can put it in front of the staircases, or you can put it over non-regularly occupied areas, just like storerooms, washrooms, staircases. You can put glass over those which are non-regularly occupied areas, and you must use glass and the shading devices in addition to it, where the shading devices, or you must use the shading devices over the glass where there is complete regularly occupied areas. So latest energy efficient HVAC technologies here, we need to first provide natural ventilation and to maintain minimum equipment efficiencies. Like if we are using split air conditioner or window air conditioner in our buildings, so we must need to achieve the 3-star minimum as a 3-star, and it is also recommended to use 5-star air conditioners in our homes. And we must need to use the automatic controls in our buildings, whether it could be home, residential, or any office, government or private buildings, whether it could be commercial building. So there are some latest energy efficient HVAC technologies, which are VRV, VRF, chillers, district cooling, radiant cooling, geothermal. So there are some of the technologies like geothermal or radiant, which is irrespective of the refrigerant techniques. So they are not using refrigerant because we all know the refrigerant which also cause the and directly impacting to our environment, and it is causing the carbon emission and the climate change impact. So we must need to dependent upon the evaporative cooling system, geothermal or radiant cooling system, or there is a provision where we are using VRV and chiller and system, VRV chiller and district cooling. We need to integrate it with high COP like more than 5.6 or 5.8 in chillers and more than 3.6 COP in the VRF systems. So these are the major requirements which we need to use and more focused. Another is the integration of renewable energy. Renewable energy we need to integrate because we need to offset our energy consumption and demand with the energy consumption with the energy generation part, so that our buildings would be majorly near net zero energy building, because the energy consumption, when energy consumption of your building would be offset by or would be compensated by the energy generation part, your building would be directly net zero energy building. So this is one such example. This is from Punjab and Ludhiana. It is located at 2.5 megawatt canal top solar power plant. So we this is how example we how we can use and integrate the solar panel generation of solar energy through the water streams as well, so that it will not consume more natural land, which will enhance energy generation part as well. So there are some such green buildings rating system as well. 4 types of rating system in India. First is Griha, second is GEM, third is IGBC, and fourth is LEED. 4 types of rating system in India. there are several factors, there are several parameters which where they are performing. GRIHA is varying from 1 star to 5 star. GEM is from GEM 1 to GEM 5. IGBC is very certifying from silver, gold, platinum certified, and same as per LEED USGBC. So what type of rating levels for, so all such rating bodies are describing and giving you recognition as your building would be meeting all such requirements which are defined under the green building standards, like as we already discussed, to reduce the water efficiency, to reduce the water consumption in the building, and to reduce the energy consumption in the building, to reduce waste generation, to provide healthier space for occupants, and to maintain the better indoor environmental quality, which is utmost important these days. So the benefits or advantages are, we can save 30 to 40% of the energy saving, average for 25% of the water savings, extra FAR in Indian cities we can get as per the government notifications, reduced operations cost by 19%, better market value of the projects, and it can promote the renewable energy. So these are all comprising of advantage of green buildings. So these are such case studies which for your reference only. So this is one such example, Indian Indra Paryavaran Bhavan, which is the GRIHA 5-star rated building and India's one of the first net zero energy buildings in India, which have been designed by some renowned architects, and it is constructed by CPWD, and it is used by MOEF, Ministry of Environment and Forest officials. Another is Indian Habitat Center. So this is another such example. We have 5-star rated building, and the design and construction you can see in such a way that it is consuming less energy, and the energy consumption is as low as possible, and the total they are maintaining a green ecosystem or the landscaping part as well, so that this building is one of the best green buildings, 5-star rated building. Another case study I can see you, this is reference from Jhanjeri, Kartarpur at Punjab. So we are involved in this project, and this is one such building where all the globe-based structure have been designed, and in the wall, roof, and glass, all parameters have been checked in such a way that this building would be most energy efficient building. Like they have implemented cavity wall with fly ash bricks and styrofoam insulation in the wall assembly. In the roof, they have constructed heat reflective tiles over the RCC, and below deck they have used the insulation and false ceiling. Building envelope glass, they have used double glazed glass and the UPVC frames. Heating, ventilation, and air conditioning. VRV system they have implemented with 3.6 COP, which I have just told you. We need to achieve the 3.6 COP if we are using VRV systems, or above would be more recommended if we can go up to 3.6 COP as well. Electrical systems, which is LED lightings, sensors, transformers, cabling, power factor 0.96 minimum, they have achieved. Acoustics, all the auditorium have been designed in such a way that it has been designed on the verge of Parliament auditorium. So auditorium with proper acoustic insulation and the sound system, and metering and monitoring is BMS system with complete metering and monitoring system they have developed inside the building. They have a separate room where they are monitoring each and every room or each and every floor, so that their energy they can meet the energy performance requirements for energy saving in the building. So this is an example. We are sitting, and from PEDA we are already make them people aware about energy efficiency in the building section, whether it would be commercial or residential. And if this building is designed in such a way that it is not required more than 90%, it can be reduce the artificial lighting, and more than 80 to 90% of the HVAC requirements have been reduced. The buildings it has been designed in such a way that it can enhance or capture more natural daylight, and the natural ventilation or cross ventilation have been designed in such a way that there is no much HVAC requirements in the building. And it is also B 5-star rated building. It is located at Chandigarh. We are sitting here. So this is one such example. Case study is from Hareda. Hareda is also one such building where they have designed and constructed. It is GRIHA 5-star rated building, and they have implemented the misting features. Do all the corridor or the central atrium area have been designed, and it has been cooled with the uh, misting part only, not required the HVAC directly. So they have used the double glazed windows integrated with the renewable energy technologies. So these are all such parameters which they have used, designed, and constructed. So ECBC resources, you all can refer it. Tip sheets, user guide, notification incentive, and app is also available on the Google Play. You can download it and can search and read about more ECBC resources. And you can also go through PEDA website, which can also help you to get some resources at free of cost. So way forward to implement and design in design and construction of the upcoming buildings, and every stakeholder, whether we are architects, whether we are builders, whether we are consultant, contractors, and engineers, we should provide extended support to make ECBC compliant building in each and every state. And it must be the climate responsive building. It's climate responsive building. It should be, and to maintain regular mechanism. So the futuristic buildings. This is the type. Are we going to build such type of buildings in the near future? These are the futuristic buildings. I can see, and I was reading in some blog yesterday, and I was attending one webinar which where there is one renowned architect from India was one of the panelists, where they have mentioned we are going to one place where this coronavirus have during this critical time, it has give us a lesson that how we can run and operation our buildings, how we can work from home, all the things we can integrate, and how could be the futuristic building we are going to develop in the near future time in our urban areas. So are we going to build in such a way? We are going for much taller buildings, and every requirement or every daily requirement, uh, we can meet it within the building itself, within the community itself, and the traveling and everything would be lesser in the upcoming time, and we all can work from home, and we can connect it across the globe. And the building features, whether it could be design and construction, we need to develop in such a way that the building would use conserve more natural resources, whether it could be natural sun, natural light, natural air, to circulate natural air within the building, natural sun, so that we can generate it more electricity generation, even through the geothermal or biomass or the solar PV systems as well. So these are some futuristic building we are looking for, or we are going to develop in our urban areas or urban cities. So these such examples which I have get from the last architecture design and construction part. So these are some reference. So this is good example how it is going to shade the street as well, and the building capturing more natural light, natural sun, because it is complete the a separate portion of the glass as well. It can capture the natural daylight, and the natural flow of air can also be maintained. So, but we need to also learn something from the past as well. How the building have been constructed, the most traditional buildings, or we can say the ancient buildings. We can learn it from the past as well. So we need to integrate how the Hawa Mahal, Taj Mahal, and the various such forts and the big buildings which have been designed and constructing. It is operational. And we all can see when we are sitting inside the Hawa Mahal, or we can roam around the Hawa Mahal, we can have a cool air where there is no directly heat gain inside the building, and there is no HVAC system, there is no artificial lighting, and it is good energy efficient buildings. So we need to integrate our design and construction so that we can implement the greenery. More greenery we need to integrate in our buildings as well. So now it's time to over. It's just 5-5, and our objective is to save our planet and to make eco-friendly and environment responsive buildings, which would be energy efficient and the green buildings. Our objective is to save our planet and to achieve the sustainable goals. Our sustainable goals is to reduce the energy consumption, to reduce the water consumption, to reduce the waste, and to integrate with renewable energy systems and the e-vehicle, because e-vehicle is the next generation, and the vehicle charging station we also need to integrate. This is our sustainable practices and the sustainable goal. We must need to achieve it and set AC at 24 degree, which is the government campaign which we are running, because the summer season is coming up and all the air conditioning will started operational within a few days after. So our set AC at 24 degrees Celsius, because when we are running AC at 18 degree, and after few hours and we can take a blanket and we can sleep. So it is we are just implementing and incorporating air conditioning in our rooms only because we need to have thermal comfort requirement, or we need to meet thermal comfort requirement inside our buildings. So as we all said, our thermal comfort requirement being a human being is around 22 to 27. So we need to achieve set AC at 24, and we can run our building at 2 to 3 speed. So take that, and target is to reduce the energy consumption in our buildings. So yes, the future ends with us. Save planet, save earth, save energy, save water, and save waste. So yeah, this is my last slide, and thank you very much for your patience hearing for this session. And now we can have any questions, so we can have it from the chat window. Chat window, if you have any question, then you put it in the chat window, and we can answer it one by one.
Hello, Manikandan sir.
Yes, sir.
Hello.
Anji?
Hello. सर सर्विस हो रहा है जी. हेलो हेलो.
हाँ जी बोलिए सर,
Yes,
अजीत
yes.
बोलिए.
सर ECBC ऐप क्या चाहिए सर? ECBC
क्या करें सर?
सर ECBC बताया. ECBC ऐप है कोई प्ले स्टोर में आपने?
हाँ जी ECBC ऐप है सर. ECBC हाँ जी.
ये इसको डिजाइन सॉफ्टवेयर सर, ये जो बता रहे हैं आप?
हाँ जी.
हेलो हेलो
सर हाँ जी प्लीज सर बताएं.
सर ECBC जो ऐप ECBC ऐप बता रहे हो, ऐप में सर क्या करते हैं हम ECBC में?
सर उसमें जो आपके जो रिक्वायरमेंट्स है, जितने आपने जो बात की, द कंफर्ट सिस्टम एंड कंट्रोल्स और लाइफ ऑफ बिल्डिंग एनवेलप, सो आप इसी ऐप में सारी चीजों की रिक्वायरमेंट को पढ़ सकते हैं. और जो यू वैल्यू और एसेट की हम बात करते हैं, कैसे हमें यू वैल्यू को मीट करना है, सो आपको एक ही ऐप में सब कुछ पता चलता है.
ठीक है सर. ऐप है प्ले स्टोर में ये?
हाँ जी, ये गूगल प्ले पे अवेलेबल है सर.
ठीक है. थैंक यू सर. थैंक यू. ओके.
So there is a question from Himanshu. As we can see that the U value of the glasses has been improved, and PVC shutters are also available, sensor based, which relates to east, west, south, etc. direction. But we still not able to make client work like this. So any guideline mandatory for glass and shutter need to address in different codes like leads, because no, there is no such mandatory requirement. There are only requirements that you need to put glass which are having U value and SHGC. You need to achieve only U value and SHGC of the glass requirement, and in addition to it, your VLT should be more than 30%. VLT means visible light transmittance. So this is the only requirement, and all such codes are defining in such a way that your glass having U value SHGC, and you need to meet, and your window wall ratio should not be more than 40%, because in Griha your ECBC would be mandatory. In GEM is your ECBC is your mandatory. As old building has a very good ventilation and high ceiling, but in compact spaces we are having like any design choice to meet that goal of any old building. Yes, you can include, if you would not like to add the thickness of your wall assembly, you can put the insulation only in addition to your building material. Like if you are using fly ash bricks, if you are using perforated bricks, or the AAC blocks, you can integrate AAC blocks with insulation. Your requirement for ECBC will be fulfilled. So yes, if we need to, there is a question from Sahil Sharma. If we need to integrate solar panels within our buildings, so buildings in Chandigarh, how much area and how much energy can be generated by it, considering the climate of our city? Yes. So if you would like to integrate solar panels at your home or at your office or any commercial buildings, so it requires 100 square feet area for 1 kilowatt solar PV installation. 1 kilowatt solar PV installation required 100 square feet area. So 1 kilowatt of solar PV system can help you to generate 4.5 units in a day. 4.5 units in a day, a 1 kilowatt solar PV system can generate, and 1 kilowatt system can save up to 10,000 rupees in an year if you will install 1 kilowatt system, which would cost around 50,000 for per kilowatt, which you can install at your home in Chandigarh. As yes, you Chandigarh. Yeah. So, Jitendra Vyasji from Indore, excellent presentation. You have covered everything in stipulated time. Wonderful. And can you please suggest some good energy and lighting software, simulation software? Yes, sir. As I'm sure we all know, we are working in this energy building energy industry, and we are working on energy simulation for each and every project, like on ECBC or green buildings. Whether any project we are handling, we need to work on energy simulation. So there are many software. If you can see the ECBC 2017 book at the last page, there are several software enlisted at the last. So energy simulation software, first is the more than 90% energy, more than 90% professions in India are using eQuest, which is available at free of cost. And in addition to it, we can use the Energy Plus software as well, which is also free of cost. We can use the Design Builder software, which is another software is IES, Integrated Environment Solution, IES software, and we can also use the Trace and Open Studio. So these are 5-6 software which are majorly and commonly used by the all energy professionals across the globe. But if you can see in India, more than 80% or 90% energy professionals are using the eQuest, which is open source available, and it is available under Department of Energy website at USA. So this is the energy simulation and lighting simulation software. The one of the simulation software is the DaySim. We generally use Ecotech, but now it is not authenticated and recommended under BE or ECBC 2017 book. So we can use the DaySim or IES or Design Builder. So majorly three software we can use, and it can be integrated to achieve our goals. Yeah. Imran Hussain, can we use limestone in construction like in acid? Yes, we can use. There is no harm in it. We can use, but it must. We need to check how the thermal conductivity, thermal property of that material, and also we need to check for the thickness as well. Because if you can consider Taj Mahal, Hawa Mahal, or any ancient buildings, or any ports, or like uh, um, the Nahargarh forts, or many forts are also in India where the thickness of the wall assembly or roof of assembly is much more. But during this today's time, there are the area have been restricted. Area is also restricted, and cost of the land is also increasing day by day. Cost of the land. So we also need to integrate uh, and check whether this material at this thickness it is competing our ECBC requirement or green building requirement or not. Yes, we can use all such material, but we need to check the thermal conductivity value. And another is, what is the relation between green building star number with green building? Gray building. Uh, I'm not sure what is gray building. Grah building, it might be the Griha building. Star number, star is every rating system have a different system. Like Griha is rating from Griha 1 star, 2 star, 3 star to 5 star. Gem has a rating usually from Gem 1, Gem 2, Gem 5. If you can consider it in IGBC, they can usually rating it as certified silver, gold, platinum. So they have a specific standards and they have specific criteria. Like if you have maximum number is 90 or maximum number is 100, so you need to achieve minimum 90 to achieve it at platinum rating. And if you would like to achieve gold rating, you must need to achieve 80 numbers. So there are some credits available and which are mentioned only in the standard rating. So this is the only comparison with the green rating systems. Yeah, there's a question from Mr. Ramandeep Singh. You have mentioned here that energy efficient building get compliant from Griha, LEED, etc. IGBC. So I am requesting you to kindly apprise ECBC. Punjab ECBC compliance is different from other rating system, and from which authority we get it. So, sir, as I already mentioned, ECBC is the mandatory version and which is also enforced by the state government like PEDA in Punjab, and it is also incorporated in the building bylaws. So it is a mandatory part which you need to achieve all the requirements anyhow in your building. Griha, LEED, and IGBC, these are just voluntary approach, but you can get it to make your building as environment responsive building. There are 4 such rating systems. You can implement any of the rating system in your building, but the government is also encouraging, because you are developing the energy efficient or the environment responsive building. So Griha, LEED, etc. There are few rating bodies which I've already mentioned you. You can get it certificate from any of the rating system, and you can get 5% extra, 5 to 15% extra FAR from any of the rating system. So there is no government authority directly involved. So there are basically consultants, and you need to integrate with the rating authorities. If you would like to choose for like Griha, if you would like to go for Griha, and you can get in touch with the Griha team and their website. You can search it on their website. You can send an email who we would like to register. So you can your project can make a registration. They will help you to get your building certified from the rating system, and you can achieve the certificate. Can we convert an already constructing non-green building to green building? Yes, there are many buildings which are green buildings. There is a one parameter which is existing green building system, which is available with all the rating systems, existing building standards, where your building will be analyzed how your building is currently performing at energy level, at water level, at waste level. Everything it will be checked as per the existing operational conditions, and then after that it will be recommended to you, and then suggestion are being provided to you that you need to integrate the energy efficiency measure, energy conservation measure. You need to integrate water efficient water conservation fixtures, or you need to integrate the waste conservation features in your building, so that your building can be directly converting from your non-green building to green building. yes, your existing building can be converted to it. I am an energy manager. There is another question from Mr. Harish. I am an energy manager at company and retiring next level. I want to indulge my life in building sector energy conservation. Please suggest way forward. I have learning attitude and applying for being accredited energy auditor. Yes, sir. If you are already an energy auditor and accredited energy auditor, you can conduct the energy audits for the existing buildings as well, for the existing industries as well, like MSME or short small industries. You can conduct some analysis depending upon the operational existing characteristics, how their building are being constructed, and how it can be more better operational irrespective of the cost features and the energy efficiency part. You can involve and you can get it certified, because there is also another exam which would be released by Bureau of Energy Efficiency shortly. B would shortly release another exam which would be ECBC building auditor. So we can involve in that, and we can also get it certified, so that you can also work as an independent, and your interest would be definitely be continued in this building energy efficiency sector. So whether Chandigarh administration has issued, there is a question from Sly 218. Whether Chandigarh administration has issued any notification or for completion of compliance of ECBC. I think in Chandigarh, if you can consider it in UT, there is only at the voluntary approach. It is not yet mandatory notified. So it will. I'm sure it will be implemented very soon. But they are just designing and constructing each and every building as an energy efficient building. So if you can consider in Chandigarh, every building they are designing, and you can see the Chandigarh architecture, Lee Corbusier, major buildings have been constructed. So they all are designing and constructing in such a way that it will consume less energy, less water, less waste. So yeah, there is another compliment from Mr. Vikram Jadka. Thank you, sir. Aniket, which agency give this certificate for green building? I've already mentioned you. Griha, GBC, LEED, and GEM. These are the 4 rating system. Jajati Sen, do we have any green certification for buildings in oil and gas industry? Yes, every type of building can be certified as green building. Ramandeep Singh also provide. Thank you, note. Thank you, sir. Akashdeep Singh, can our home also be rated with stars out of 5? Yes, very soon. Or it has already been launched by Bureau of Energy Efficiency at national level. You can get it certified. You can register your home. econivas.com. There is a website. You can register your home, and you can get your home as an star rated home. There is a minimal fees, I think 2,500 to 5,000. I think you can get in touch through the team. You can search it at econivas.com. So you can directly get in touch with the team, or you can share your email to us as well. We will connect you to the GIZ or B team. Every home very soon will be certified as a 5-star rated home, or 2-star, 3-star, whether depending upon the operational characteristics. Every home will be classified as the energy efficient home. How we can become energy auditors? Sir, Venkatesh ji, very soon, one exam would be released by Bureau of Energy Efficiency, and you can have some notification from Bureau of Energy Efficiency website. Very soon it will be released, whether it in the next 3 or 6 months it will be released. You can enroll for it if you are having sufficient experience in this building energy efficiency sector, or if you have any credential before going for this directly ECBC building auditor. So you can directly go for it. You can enroll, and you can get it certified from Bureau of Energy Efficiency, and you will be recognized as ECBC building auditor. Another thanks note from Harish. Thanks from Harish. Yeah, thanks. Venkatesh sir, airports are also made on green building. Yes, many of the green building, all the airports, like if you have seen the Kartarpur corridor, which connects us from India to Pakistan for the through the Kartarpur corridor. This is also one such corridor have been designed as a green building. So every airport you can see at Delhi, Mumbai, Bangalore, Chennai, uh, these are all airports in India which have been designed and constructed at the requirement and meeting the requirement of green building, and they have achieved the green building certification. Even Chandigarh airport as well have been designed and certified as a green airport. What are the master's course in this field? As I'm graduated in me. Okay, Kasdevji, you can get enrolled with many of the institutions in India where you can get this course. You can get it enrolled through MNIT Jaipur as well, NITTR Chandigarh, where you can get many of the courses running in parallel, where you can get the master's course related to this field. You can get it from SEPT University Ahmedabad. You can get it from IIT, any IIT, or SEPT University, Triple IT Hyderabad, MNIT Jaipur, and Delhi University as well. Delhi University has many courses for master's course in this field. All IITs have, because masters in construction management or the green or sustainable construction practices. All institutes are also doing. All architecture institutes are doing MArch or masters in sustainable architecture. So you can get it enrolled from any of the institutes. Yeah, right. We are very much thankful. So we have received now, Sundarlal ji, we have received a thank you note. So thank you very much. So now the answers have been, all the answers have been responded. So Shalom ji, please take it forward now.
Okay, Mr. Manikhanna, on behalf of CGC ASHRAE Student Chapter and McMortal Club of Mechanical Engineering Department and Civil Engineering Department also, I thank you very much. It was indeed a privilege to have you as an eminent and you are a renowned BEE certified ECBC master trainer and also Secretary ASHRAE Chandigarh chapter. So the concepts you explained regarding the energy conservation in buildings were full of wisdom and technical knowledge. So like you told about how to reduce HVAC loads in building, and you also shared your case studies like Hareda building in Panchkula. You shared its case study, how it is integrated with renewable energy technologies. So I feel that faculty and students who attended this lecture, they will definitely be benefited and they will use these concepts and tips given by you in the buildings they design or in the project works they are doing. So once again, I thank you, sir, that you have spared out so much of your time for all of us.
Shalom ji,
I
please.
thank Mr. Rajesh Kumar, HOD Mechanical, and members of management for having organized such a wonderful event. So it was
Shalom ji, I think I can see in the audience, so Balkan sir have also joined. So we are also working under him. So I would also request sir to please share some few words. So under his guidance, we are working for energy efficiency in the buildings part in the state of Punjab. So we would also recommend a few words for the energy efficiency in the building parts. So Balkar sir, please. 2 minutes. Hello. Yeah, Balkar sir, am I audible? No. So right. Shalom ji, thank you very much. We have already launched our vote of thanks, and we are now moving to the end. And again, thank you very much for all of your participation. And we are signing off now. Thank you very much.